So just as I told you, to plot a histogram, we just need a single variable because the second axis or the other axis represents the frequency. Here I am plotting the data.price attribute using histogram. So while I do that, we use the function go.histogram. While I do that, now I can see that in the price range of 115 to 119, a total of 1758 people have stayed in this particular price range, or like they have paid this much money to stay. Okay. So moving on to scatter plots. Scatter plots, if you guys have learned about linear regression or regression itself, then you must know what scatter plots are. So scatter plots basically show the relation between two different variables, two different numerical variables. So we have one variable on the horizontal axis and the other on the vertical axis, or yeah, on the y-axis, and then we plot the data points like this. So scatter plots are very handy when we want to find out the relation between both the variables. Just like you can see in this graph that first we plotted all the point, and then we can find you know appropriate fitting line like this, which is going like this. So this is the fitting or the relation between the two variables. So there may be multiple values of this particular relation, which can be positive, negative, strong or weak, or it may be linear or non-linear. So here we can see that it is obviously non-linear. A perfect linear relationship would look like this, somewhat like this. And since the slope is positive here, it is also known as positive relation. If the slope would be negative, it would be negative relation. Then strong relation is known as when the correlation coefficient value is close to 1, and if it is close to 0, then it is known as weak relation or weak correlation. So let's see how we can plot scatter plots. So for scatter plots, since scatter plots is a correlation between two different variables, since scatter plot is a relationship between two different variables, we'll be needing two variables to plot. So on the x-axis, I'm taking data.price, and on the y-axis, I'm taking data.overall satisfaction. And let's see what is the relationship between price and the satisfaction of the customers. But here, after plotting this scatter plot, we cannot actually find any relationship as such. So we can say that the price and overall satisfaction are not related. So then here is an example to show you how to plot a 3D scatter plot, an interactive 3D scatter plot. Here I am taking one more variable which is data.accommodates along with the overall satisfaction and price, and let's see how these three try to correlate with each other. So here here we have price on the x-axis, overall satisfaction on the y-axis, and the number of accommodates on the z-axis. And maybe you guys can see for a less number of z, the value of y is greater. A value of y is greater, that is the satisfaction of the customer is greater for the less value of uh, for a less number of accommodates in the room or in the hotel. So then but here we can see that this graph is informative, but it is not clear. So for that we need to provide the title for the graph. We need to provide what x-axis represents, what y-axis represents, and for this we need to define an object named as layout, which can be initialized using go.layout. And after defining title, x-axis and y-axis, we can just feed it into the go.figure function, and you can see now the graph looks more professional with the title, x-axis and the y-axis legend in it, right? Uh, then there is one more thing we can do with scatter plots and plotly. We can create graphs like which are known as bubble plots. So for bubble plots, using a 2D graph only, we can express more and more and more and more data. So like here with here the size of the marker is nothing but the number of accommodates. Okay, so if the number of accommodates is more, the size of the marker would be more, and if it is less, then it would be less. So seeing for the 420 thing, so we for the price of 420 uh, and the number of reviews on the y-axis, we can see that here we have 51 reviews and the bubble is great. Bubble is comparatively larger than these values which have 34 reviews or 37 reviews. So we can see that more the number of accommodates have given more reviews, obviously. So it is a way to represent or to analyze more data using a 2D plot only. We do not need to actually create 3D plot to see the relationship between all these three. We can also infer three variables using this marker attribute here, and these are known as bubble plots. Then using this marker attribute only, you can also define the size, color, or you can also define a boundary line of these markers. You can change the shape of them, you can change the color of them, and many more things. There are one more kind of plots which are also considered in the scatter plots only. So these are known as multi-line plots. So in multi-line plots, we what we do is we first plot two different attributes, and the mode is now changed from markers to lines, and we can see a plot like this. So using these multi-line plots, we can analyze both the attributes, like change how they change or how they vary, uh, and we can also see the respective difference in both of them. So we can see that the red one, which is the reviews, they are almost constant throughout, but the price is usually fluctuating. So by changing this mode from lines to markers plus lines, you can get even more information, like you can get where your data points were, which was not so much clear in the above plot, but here you can always see where your data points were. So the next is box and whisker plot. So a box and whisker plot is also known as a box plot, and it displays the 5-number summary of the set of data. It is the most informative plot, I guess, because it tells you a lot about your data. So if you plot a box plot for your data, it will tell you Q1, Q2, which is median, and Q3 of your data. So it is represented by a box, and it then gives you the IQR also. The middle line of the box is known as the median itself. Then we have these lines which are known as whiskers, and these whiskers are nothing but 1.5 into IQR, and after this particular line, whatever data is there, they are considered as outliers, right? So yeah, so this is what a box plot is. So let's see how we can plot this in plotly. For box plots, first we need to do some data processing, and here what I am doing is I am taking the price of I'm taking the price of homes, the price for entire home, prices for personal room and the shared room, and then I'm plotting the box plot here. So After plotting the box plot here, we can see that the distribution of all these three attributes, which is entire home and apartment, private room, shared room, is definitely different. And we can also see the Q1, Q2, Q3 and the IQR, and we can see these are the outliers here. So all the five data attributes which box plot shows or which box plot returns, we can see all these five attributes, Q1, Q2, Q3, whiskers, IQR, and the outliers. You can also plot the box plot in the horizontal direction by just changing this attribute to X from Y. Like here it was Y, and if you change it to X, you can plot the box plots on the X-axis or the horizontal or in the horizontal way. The next plot which we have is the violin plot. So violin plot is just, we can say it is just an extension to box plot, because it provides all the information whatever box plot is providing, but it also provides some additional information which is usually the probability density function. So the PDF and the CDF function is also represented in the violin plots using these curves. So these curves they represents the PDF and the CDF of the data. So for violin plots, since I already told you in the tutorial, in the presentation, uh, violin plots, they, along with the information which is provided by box plot, they also provide us with the CDF and the PDFs of the data. So using the go.violin function and providing the data, the same data I'm providing which I used for box plot, I'm plotting the violin plots here, and to give the colors here, you can definitely, I am using light sea green, deep pink and sky blue. These are defined by Plotly, so if you want to see what all colors are there, you can just go to the Plotly docs and you can see that. So after plotting this violin plot, we can see that this much information it was provided by box plot also, but these curves which we have here, the curves outside the box, these represents the probability distribution of the data. Similar to box plot, we can also plot these violin plots on the x-axis or or in the horizontal way, changing the same thing again, changing this to x instead of y. The next plot which we have is the pie chart. I guess all of you must be aware of pie charts. The pie charts, they are really useful in business analysis, and in pie charts, we have the categorical data, and to represent the numerical data, we just divide the, you know, chart into, or we just divide the circle into different pies of data. So like this, we can divide the uh, data here, like we have fog 1%. So suppose this, so suppose okay, let me construct a pie chart for you for let's say contribution of phone companies or mobile companies in the global market. So if we do it like this, we can see that we can say that around 30% of the market is provided by Samsung, or maybe 26% is provided by Apple, or around 15% is provided by OnePlus, and the rest is provided by, you know, small manufacturers like MI or Huami or Huawei. So like this, we can always divide the, you know, whatever our quantity is, based on the quantity we can divide the categorical data or the qualitative data qualitative variables into the pie chart. So in a pie chart, the arc length of each slice and consequently its central angle and the area is proportional to the quantity it represents. Okay, so let's see the demo of pie chart, how to create a pie chart in Plotly. So for pie charts, we have another inbuilt function named go.pie again. So here we need to provide the labels, which will be the categorical data, and the values, which will be the numerical data which it has to represent. So after plotting this curve, we get this pie chart here, which represents this blue area represents the entire home and apartment, this orange represents shared room, and the green one represents private room. So what we can infer here is since like more people are more people accommodate in entire home or apartment or shared room as compared to the private rooms. So maybe the company can focus on these two sectors even more as compared to the private rooms. So this particular elevation which I have created here, it can be created using the attribute named as pull. So I had three labels with me, so I pulled the second label by a value of 0.1. So this is just to uh, create a good visualization effect. Then pie charts who have which have this circular cutout or the hole in between, they are also known as donut charts. To create donut charts, we just have to put another attribute named as hole and then provide the value of this hole. So that was it about the basic plots, but I wanted to show you some advanced plots also. The first one is the geographic plots, and as the name suggests, it shows the data on the geographic map, and it helps us to infer from there itself. So for here I have a population data set which I downloaded, and it shows the population of most of the countries from 1997 to 2019. But what I want to do here is I just want to have the population of India and its neighbor countries like China, Bangladesh, Bhutan, and Sri Lanka, and then I create a new data frame which has only the population of 2019 and for these countries only. So here we have the data itself. Then we have to create the data object of the graph. So for this, we need to define for the geographic plots, we need to define the type as choropleth. Then we have to define the locations, which we just now created. We can take it from new pop locations. New pop represents new population data frame. So then location mode is set to country name, and we have something known as color scale. So color scale RDBU means red and blue. So we have different color scales in Plotly, like Portland and others, which you can always see on the Plotly docs. Then we need to provide the value itself. So the value is given by new pop 2019 because we only want the population value of 2019. Then we create the layout object in which we set the geolocation, and the scope is Asia because we are talking about India and its neighbors. We can change the scope depending on our requirement. Then we just provide this data and layout in the go.figure method, and we plot this graph. So after plotting this graph, we can see here the population of different countries. So based on the color, we can see that the red represents lowest population and blue represents highest population. So India represents so India has 1.36 billion population in 2019, and while China had 1.39 billion. So we can see this reddish color here, and which is dark red means it has very low population. So Bhutan had 763,000, while Bangladesh had 163 million. So depending on the color shade, we can now say that okay, so this is the darkest. So that's why China had the most of the population. Then came India, and we can see Bhutan and Sri Lanka had least populations. So previously I showed you one 3D scatter plot. So there are more 3D plots, one of which is one of which is known as surface plots, which I find very interesting. So this is a data file which is provided by Plotly, which is data of Mount Bruno's elevation. So we just take this data and we just put it into the go.surface function, and we plot this data. So here we can see that so therefore here we can see Mount Bruno's elevation. So you can also, like, since it is again an interactive graph, you can see it with different angles. You can interact with it, you can infer from it, and as we can see, the color scale is from dark blue to yellow. The dark blue represents less depth, or sorry, the zero height, while yellow represents great heights. So the peak of the Mount Bruno is somewhere around 372. We do not yet know the unit, but we surely know that it is the peak because it is the yellowish color, or it is the most yellow color. Then so this was the thing where the data was given to us, but if you want to create your own surface plots, own 3D surface plots like this, you can always just define x, y, and z data, and you can just do figure.show to create these kind of surface plots. And yeah, so there is one extra thing about this. Here we have something known as contours. So these lines, these circular lines on the z-axis, which you can see, these lines, which you can see these circular lines, these are known as contours, which we had given here. So if you want to draw these kind of lines, which are useful in data inferencing a lot of times, you can just provide the axis on which you want to show the contours, and the starting and the ending position of the contours, and the distance between consecutive contours. Also you can define the colors. So on the x-axis you can see we have these four contour lines, four or five contour lines. So since in the function we have set the contour in the x-axis to start from 1.5 to 2. So here you can see the contour starts at 1.5 and it ends at 2. So that was it for this particular module. I hope you guys get a good understanding of what Plotly is, what data visualization is, and how to plot cool graphs in Plotly. You can always just go to Plotly's website and see the documentation if you want to plot more and more of these graphs. There are many other graphs which were not covered in this particular module, as this was an introductory session, and we have covered most of the basic graphs only. Still, if you guys have any question, feel free to comment below and we'll try to answer your questions as early as possible. So if you like this video, please hit the like button, please click on subscribe, and please click on bell icon to get the latest update from AI Probably. Thank you.